Hey, it's Jag, and today we're doing off-board wires.
Yeah.
Today we're installing the off-board wires to the components on the front and back of the chassis. We also will be putting some components on the chassis controls, so let's get right into it. So as I said, we're installing the wires and the components mounted to controls. We're going to start over here in the lower right with this first blue wire that goes off this second turret at the bottom right and goes to pin 3 of V1. We also will be then mounting the grid resistors from the terminal strip to pin 2 of V1. From there, we will be working our way around the board clockwise, installing the wires and various components on the tube sockets and on the front panel controls. So we will just do them sequentially as we go around. So I will show you the installation of this first off-board wire, this blue one, going from this turret to pin 3, and I will also show mounting these 268K resistors on the terminal strip so you get an idea of the procedure and how to mount those things cleanly and neatly. Once that's done, I'll just go through and do all the rest of the wiring, and we'll go through a rundown once that's done. You want to make sure that you pay particular attention to the color coding. Wire is just wire as far as electricity is concerned, but if you follow the color coding of the wires, it will make it easier for you to trace down the road if you have any issues or you're trying to figure out if everything's going to the right place. So there are basically 3 ways you can connect wires into these turrets going off board. That is, as I said before, from the bottom. It's not really my favorite way to do it, other than it looks somewhat neater. And I'm not going to do that here. I detailed that in the build of the Triwatt, where I did install the wires under the turret board. So you can check that video if you want to see how I did that. On the top, there's essentially 2 ways that you can put these wires on the turrets. You can either strip the wire and put them into the hole with the other components and solder there, or you can strip a little extra wire off and put it around the outside of the turret. Just crimp it around and then solder it outside there. That can be a lot easier if you got a turret that has a lot of leads already in it. You might not be able to fit another wire in. For example, down here where I have this capacitor, there's 3 leads going in each of these turrets, and there's not a lot of room there. I'm just going to strip a little bit of the end off this blue wire that we're going to be installing over the end, but just checking whether I can get that wire into the hole in the top of the turret or not. Basically, I like to have everything look consistent. So if I can't get that wire in the top turret there, I will be putting the wires around all of the turrets. There are a lot of reasons to do that anyway, and I may choose to just do that. For one thing, if you do some modifying and you're going to, say, bridge a resistor with a capacitor to either bleed high end to ground or let high end go around that resistor, you might need to add that component in there after the fact, and then that wire would be in your way. So what I'm going to do is I'm going to take this little stripped end of this wire, and I'm just going to check all of the turrets that I need to put off-board wires in and make sure that the wire can fit in there, and it does. It does fit here. It's a little tight in this turret here, where I have 3 components going in. I also have 3 components going in the turret next to it, but yeah, I'm not having a problem getting the wire in there. So it looks so far like we aren't going to have a lot of problems putting these off-board wires in. Like I say, the only issue may be down the road if I do a modification on this, and I find I want to add another component, say bridging across a resistor. I might find that that's a little bit of a tight fit. So I can get those wires in the tops of the turrets very easily all the way around. So I'm going to put these wires in through the hole in the top of the turrets. As I said, you could put them around the outside. It's a little bit more finicky to solder. And you might want to, if you're considering doing that, you might want to solder your off-board wires around those turrets before you install any components on the turret board or put the turret board in the amp. If you did do that, you would cut your wires a little bit extra long, so you definitely have enough to get to the components. The other reason I wouldn't want to do that is for a very similar reason to putting the wires through the bottom of the turret board. You'll have all these wires flying off that you're going to need to then strip and bend and put in place. Once these wires are soldered on, they're a lot more likely to break when you move them around. So this way I can cut my wires to length, bend them to shape, then install the wire into the turret and to the component at the other end without stressing that wire too much and risking breaking it. Before you solder them, and especially where the wire's in the jacket, you're not bending the wire quite so sharply. So it's not likely to break inside the jacket unless you're bending it a lot. And what we want to do is we want to make sure that this wire is going to be long enough to go to pin 3, in this case, of the 12AX7. Once the wire is soldered in final, we're going to bend it down over the edge of the turret board down to the chassis, then run it flat along the chassis to that tab. So we just want to make sure that we have enough wire to do all of that. You can kind of eyeball that. If you take a little extra, you cut off the excess, you're going to be fine. Once you have your wire stripped and you're ready to put it on the pin of the tube, you want to put just a little hook in your wire just to hook it onto the lead, and then crimp it on with your pliers. Don't crimp it super tight. You may have to take this wire off down the road, but crimp it tight enough that you have a decent mechanical connection of the wire, as well as the solder connection that you will be doing. Okay, so I've got that blue wire soldered in at both ends. Now we're just going to push that wire down and run it so it's neat and clean. So the next thing to show you is putting on those, is installing those 68K input grid resistors for the low and high inputs on the front of the amp. So a coaxial cable will come from the inputs at the front of the amp and go along this side, and then will also connect to these two terminal strips, one for the high input, one for the low input. And then those 68K grid resistors will connect to pin 2 of V1 right here, one each from each of these terminals. And when you're installing these grid resistors, you want to get them as close to the pin of the tube socket as you can get them. So it can be tough to get both of those leads into the pin at the same time. So generally, what I do is I take, when I have to put two components in like that, I will take one resistor and wrap its lead around the lead of the other one, and solder that so that they are connected. You can see that here. And then I only have to work with putting this one lead through that pin. Another thing that you can do if you're concerned about the length of the leads and maybe that lead's connecting or shorting to something is you can put a little heat shrink around the lead if you want. I'm not going to do that here because this is a pretty short section of lead. So I'm just going to trim the leads not as short as they will be once they're installed. But I'm going to trim them just so they're short enough that I can kind of work with this in there pretty easily. And I'm going to put the lead that's going to pin 2 through pin 2 first. Okay, so that's the 68K grid resistors installed to pin 2 of V1. And they go to the terminal strips. I'm not soldering on the terminal strips yet because we still have coax that's going to have to come in and solder to those terminal strips from the front inputs. Well, that's most of the offboard wires soldered. Some of the control-mounted components. I've got the back panel all completely wired. The day's getting a little bit long, so I'm gonna cut it short here. So not quite ready for testing, but definitely on the home stretch for the next video. I'll just run down what I've done today. First of all, a couple of things tied me up a bit, chewed up a little bit of time. And one of my very few complaints, I guess, about the Trinity kit, and that is the knob that they use for the impedance selector. As you can see, the set screw for the selector switch is right here, and on the other side, the set screw tightens up and pushes against the shaft of the selector switch, and it pushes it against the back wall of the switch. And if you can see, there's just a very thin wall of plastic there. So I had this same issue with the Triwatt. I don't recall if I mentioned it when I was shooting the Triwatt build, but tightening that set screw, like I say, pushes the shaft against the other side of this knob, and that thin wall of plastic actually cracks. So I didn't over tighten the switch, but I had to tighten it tight enough that when I turn the switch, it obviously can change the positions, and it's a little bit stiff there. You can hear it click. So I had it on there. It was tight enough to turn the switch, but I turned it back and forth a couple of times, and then it just started spinning freely. And that's because this little plastic wall at the back of the knob cracked. So I'm not really too impressed with that, but it's a relatively minor issue. What I did, I have over in my bins behind me a whole bunch of parts, random parts, including knobs, and I had a really good chicken head knob there. So I put that on, and I actually like the look of it. It looks a lot nicer too. I like chicken head knobs. So you can see there's the knob there. And that's a very solid knob, and it works very well on there. Like I say, I like the look of it better anyway, and you can hear it works just fine. The other problem was on the back panel as well, and it was with the boost switch. I don't really like these little tiny switches unless you can really get good quality ones, and it's hard to get good quality switches. So you need those on pedals and things like that. But on an amp, I like a little bit bigger and beefier switch. And here's the reason why. You can see that there are 3 tabs here, and the middle one actually broke off. What happened was I was putting the wires through there, and then just using my pliers to just crimp the hook of wire on there so I could solder it. And I don't know if this was just a particularly bad switch or what, but when I crimped that, the end just kind of broke off. So that set me back in terms of time, even a little more than that knob, because I had to put a new switch in. I didn't have any small switches like this, and like I say, I don't like them so much for this kind of thing on an amp. So what I did have was a very good Carling style switch. A lot more beefy. You can see that right in there. But it's quite a bit bigger too. So I had to enlarge the hole to put it through here. So that took me a little bit of time to drill out that hole. But again, I've got a good solid switch in there. Makes a nice satisfying noise when you switch it. So one thing about enlarging holes in a chassis like this, I needed to go, I think that's a 1/2 inch hole there, and it started out being a 1/4 inch hole. I could have gone with just a 1/2 inch bit and just drilled right through. The problem is twist bits, once they bite, they will grab and pull themselves very quickly through the chassis, and that could have damaged something on the other side of the chassis. So when you're enlarging a hole like that, if you don't have, you could use a step bit. That would work really well. Or you could even use a reamer in there. I didn't have a reamer or a step bit, So what I did was I just went up sequentially from a 1/4-inch drill bit up to the 1/2-inch drill bit, using every drill bit up. So just enlarging the hole just a little bit every time and went slow. So that enlarged that hole without pulling the twist bit through. So those were the things that slowed me down. So the other thing that slowed me down, and you always get kind of optimistic when you're doing off-board wires. Off-board wires actually come pretty close to being as frustrating and tedious to do as the heater wires. It's a lot of bending and shaping and measuring and making sure everything goes in there right. And like I say, they're solid core wires, so you don't want to bend them more than you have to. So you're being really careful and taking care. You can see, you know, I've run everything neatly. I want the amp to look neat, as I've stressed many times. So it just took a lot longer doing that than I actually anticipated. We've got it all wired now. We've got the grid resistors wired in here, all of the off-board wires. We've got several components already mounted on the tube sockets. I've got, like I say, the whole back panel is wired now. Over on the front panel, all of the off-board wires are running off, and they're run neatly, and they're connected to all the controls. But we have some control-mounted components still to solder. We have to solder this end of this capacitor here. We have some wires to put in between these controls, and I still have the input and output jacks to wire, and those will come over with coax around the side of the chassis over here. So still got a little bit of work to do. That won't be quite as tedious as doing this, so hopefully the next video I can do that up really quick, get these components finished soldered. Probably won't show too much. I might go through wiring the input-output jacks, because that's a little bit finicky, and there's a certain way to do that. But other than that, you won't see too much more of me doing soldering or installing components on the inside here. But what we will do is we will fire this up, make sure we've got no smoke, make sure everything's working well, and I will do all the voltage measurements. Then I'll put some tubes in and do the measurements again, and maybe do a little in-shop playing. The demonstration playthrough on this amp will still be a couple weeks down the road, but it's looking good. We're very close to done. So it was a long day of shooting, but it's a relatively short video today. It's probably a good 4 or 5 hours working on the amp today, and I haven't edited this video yet. You're seeing it edited now, but I imagine it's probably well under 20 minutes. So thanks for watching. We're definitely on the home stretch with the amp now. Check out my band, One Soul Thrust. The links are below. If you like what you hear, consider supporting us on Patreon. Please share this video. Tell your friends about it. Like and subscribe. All of those things that help get a video seen by a wider audience. And I really do appreciate that you guys do that. So until the next video, have a great week, and we will see you.